Yeah.
It's typically just decision.
It's just some, for whatever reason, if someone can't, their audio or video isn't working and they want to make a comment, we need to relay that through someone who's here in person, but I don't think we get too much of that. Okay, should we start?
Yep.
All right, we're going to get started. Welcome to the RATS session.
Good morning.
Good morning. Good morning.
Morning, Hank.
Frankie's here, so we can start, right?
Yeah, we can start
I
now.
was just trying to get it to be quiet.
All right, so I'm going to click through the chair slides. You've all seen this. This is the note well describes the ways that you can contribute in the IETF. So please, I'm not going to go through it in detail. I think it's picking up. Can you guys hear me? It seems like it's
All right.
really loud.
You need to get closer.
Get closer.
Yeah, and remote people, can you hear okay?
All right.
I'm fine.
Just a review of the code of conduct. So, extend respect and courtesy to your colleagues. Try to make our conversations impersonal, focus on the content, not on the person. And just a reminder, we're working for the better good of the internet. So keep that in mind as you're making your contribution. And we look forward to everyone contributing. We have our notes takers, so thank you very much. Links to the materials, if you don't have them, they're on the chair slides. And then we can jump into our agenda. So, but before we do that, we'll take a minute to pause and see if there's an agenda bash topic. Otherwise, we're going to go with what we have here. I will note that on the list, there was a bit of discussion around, hey, there's not enough time this time around for all of the presentations that were requested. And so we've already decided to do a virtual interim following this meeting. And there's also a poll that's been open to collect your feedback in terms of when would work best for folks. So please follow up this meeting with participation on the poll so we know when to have the next meeting. Okay, so agenda topics. If not, we will jump into the agenda. And first up is Mike. PKIX evidence encoding. And I can help share.
Yeah, that's very Hi, Mike.
Hi,
Good to Mike.
I'm Moritz.
Shaving profoundly back.
Okay, the real mic is. Slides. Do I have a monitor?
Is it working?
I don't have a monitor. That's fun.
Smaller room.
Can I
Oh,
be able to see that?
this is your monitor, right?
Well, it's
There's
probably
one
supposed
over-
to- it's probably supposed to be
There's
that
one over there
Anyway,
on the wall,
okay.
but that's
Hi.
awkward.
We've done this before. This is Straps has changed names a few times. It was PKIX evidence. It was HSM's evidence. It was PKIX 11 evidence. It's key evidence or key this Straps carried one. It's the same thing all the way through. We're now calling it evidence encoding for hardware security modules, which we think is the right balance of describing what it does without calling it PKIX, which no one knows what it is. So again, this is the document that is intended to say, does the clicker have permissions? I'm gonna have to give the clicker permissions. This is the document that's intended to say if you have a private key in a big HSM and you want to attest to the fact that the private key is in hardware and its P11 properties, it is generated in the HSM and it is marked non-extractable and marked sensitive and all the other P11 properties, and you want to bundle that up together with the properties of the platform it's in, the hardware model, hardware serial, and put that into a proper attestation. That's what this is providing a data format for, and some semantics, but mostly it's just data format. Can I click? I can click. All right. So we're going to go through just to remind the group of the general structure of the thing we're proposing, which has not changed in any substantial way since last time. And then we'll quickly go through an overview of the update since last time. We have good running code story at this point, and then we're basically asking for working group last call at this point. So the structure, we've designed this thing to feel very similar to stuff in PKIX. It feels very similar to the structure of X509 or to CMS in that it is a DARE encoded to be signed TBS object. It is a TBS evidence with claims that are structured that'll feel very familiar to anything that feels like an X509 extension or a CMS object. We've bandied over words quite a bit. We're now calling the core object an element. So this is composed of elements such as a platform element or a key element. So your evidence will have one platform element, that is the piece of hardware it's sitting on. It can have more than one key element. You could have multiple TLS keys and you want to describe them all in one attestation. So you can load up multiple key elements. And then there's always a transaction element, which has a nonce and a timestamp and other sort of record keeping junk. And that's the general structure. It's just, I mean, it would map to JSON or CBOR in a fairly straightforward way if someone was so inclined to do so. These are just type value pairs where the type is an OID and the value is some string or integer type. This is designed to be fully extensible. Anyone can assign their own OIDs off their own arcs. You can add your own elements and you can add your own claim types. So if you decided that the way we've described platform doesn't meet the needs of your hardware, you can fully free to define your own top level element that better describes your product. So this document is basically, it's the structure, it's the general structure here, and then it's a bunch of sort of default claims, defining a bunch of default claims, but again, fully extensible. You're allowed to ignore the claims we defined and do your own. Next, click. So since last time, we've updated the ASN1 module. We had a bit of a back and forth with Russ and Mike St. John's about 1988 versus 2002 syntax for ASN1, specifically around the word any, which is now gone. The word any is no longer in there, and the ASN1 module is much longer and more complicated. If you don't like ASN1, it's gotten worse. I'm sorry. As a consequence, we now had to rewrite the ASN1 module, and the document is changed, and then we had to redo our reference implementation because even though ASN1 is a presentation language, the change we had to make did affect the wire format. So it is not backwards compatible with the previous version of the draft. It's as close as we could possibly get it, but it is slightly different wire encoding. So huge thanks to Mike St. John's and Russ for helping us move that forward. Extended key usage. So this has bounced a few times. So this changed to an X509 cert. So the evidence is signed by an X509 cert, which is the AK cert. And we bounced back and forth a few times about how do you identify that this is an AK cert? The obvious thing is extended key usage, but we couldn't find a good already defined EKU for AK key. There are some in TCG, but they're specific to the TCG data formats. And so we didn't want to start steal something from TCG, and now you've got a cert that can sign multiple formats and it gets ambiguous. So we sort of need our own EKU. We took this to LAMPS in Montreal, and we were told LAMPS isn't the right place for this. You don't need a whole LAMPS document just to define one OID. So now we've buried it back in this document. So now this document is going to register an EKU under the LAMPS arc, and Russ is fine with that. And yeah, so this has been sorted out, hopefully for the last time. The sample code and reference implementations and the samples at the bottom of the draft now properly have a cert that contains this OID that's defined in this document. Yeah, we renamed entity to element. So previously we'd called things entities, platform entity. The word entity got confusing. We did a big search for more words. We tried subject, we tried component, we tried member. This has been a big exercise in bike shedding. We've settled on element. Hopefully element is fine and we don't have to have this anymore. Yeah, which ended up being, I'll just say that was like a large diff. So if you do a version to version diff, we had to change like every sentence because this word shows up an obnoxious number of times in the document, but it's a fairly insubstantial change. Drop user mods. So we've had a similar debate that I believe has happened in EAT, which is like, what is a user mod? And especially in HSMs, all the big HSMs have a way to load third-party code. trusted executions, or Enshield calls them code safe environments. There's always some way to say, like, here's an application that I built and I'd like to load it and have it run inside the hardware boundary of my HSM, maybe with some special privilege access to the keys or something. All HSMs have a way to do this. Seems incredibly relevant. If you're saying, please attest this key you're holding, the fact that there's some code that the HSM vendor didn't write that has privilege access to that code seems like a thing you'd want to attest to. But it turns out there's like no good way to describe this in a vendor agnostic way. Every vendor is going to have their own like way of describing or even of handling third-party code and the level to which it's sandboxed, and you need to describe the sandboxing, and it's all gets super proprietary. So we've given up. We're not going to attempt to do this. We've just taken it out of the draft. We figure even if we had a user mod, like immediately the data in it would need to be vendor proprietary anyway. So what's the point? So we're just gonna take it out, makes the whole thing easier. And we did a bunch of other stuff. GitHub issues, open, closed, feedback, commas, nits, better references. We do have an open issue, and this will come up later. Signature identifier. Carl Wallace pointed out we're defining an ASN1 structure called signature identifier, and there's already a thing somewhere else in the world of PKIX in some ASN1 mod in some other RFC that already defines a struct by that name. And so if you're Carl and you have ASN1 mods for everything ever imagined all loaded into the same software at the same time, there's a name collision. So that's one open issue we haven't solved yet, is do we rename our thing? Probably we should. Running code. We've done some good hackathon work. Hannes, I'm looking at you. And JP, I'm looking at you. We did some good work at the 125 hackathon, which we continued this time. So we now have a reference implementation that lives in the RATS repo. So that's the official IETF RATS working group GitHub repo. This is the same repo where the draft source lives. We now have a full reference implementation in Python. And so we structured this so the Python generates the samples that go into the appendix of the draft. So we just do Python run, and then we do markdown make, and it just sucks the thing in, and it's beautiful. And if you want to see where the samples came from, the Python is right there. And this time we also added a verifier. So you can see at the bottom there's a nice little command line, -- validate, and you provide it the evidence PEM, and you provide it the cert, and it says evidence validation successful, and then it pretty prints it for you. So that's cool. We think that's helpful for having running code. This is the hackathon, so we didn't fully get it. Turns out Python can't validate cert chains unless they're TLS certs. So I spent most of my hackathon trying to figure out how to get Python to validate a cert that wasn't a TLS cert, and I failed. So that doesn't do it yet. But anyway, yeah, this is here. So if other people want to try making evidence and get it to be validated by the reference implementation, it does that. Also, Crypto Foray is halfway through their own productionized implementation, which of course they're going to be testing against the reference implementation. So we've got a robust reference implementation, and we have one vendor who's halfway through implementation. So I think we can say pretty resoundingly at this point, draft is implementable. Neither the hackathon team nor Crypto Foray has hit any like ambiguities in the spec that need to be ironed out. So as far as we're concerned, we're now several cycles into saying this. Yeah, this draft is complete and implementable. So where does this leave us? Yeah, we have a couple of sort of nits to sort out. I mentioned this signature identifier that is a collision with something else defined somewhere else in CMS. We need to brush up the FIPS references, the sample data. We just need to make sure it's all I was literally finishing the hackathon yesterday, so we just need to square that all up. And then I think we're spitting distance from shipping this document. And that's all.
You had
That's all.
5 minutes for Q&A and 5 minutes for discussion.
Which I may be relinquishing back to you.
Could be good. It always gets eaten up.
Yeah, I mean, if you don't need the time, that's fine.
Should we do before that time? Discuss.
Yogesh.
Hi, Mike. Thanks for the excellent presentation. Yogesh Deshpande. You said your title of the document is Evidence Encoding for HSMs. Was it that specific to HSM? Because I felt that this is general key attestation principles laid out in the document and in your slides.
Right. So what binds this to, yeah, it's a fair question. Container, we're defining a container format, and we're defining a set of claims, which you're allowed to ignore. So if you ignore the set of claims we're defining, then sure, it's totally generic. The claims we're defining includes things like, did you boot in FIPS mode, and PKCS11 not extractable, which are clearly like P11 specific semantics.
Mhm.
So in that sense, this is designed for, and the claims we define are specific for PKCS11 devices. But it doesn't have to be, of course.
Yeah, I mean, because if tomorrow n number of such technologies, you will end up spawning n number of such drafts, which you could have generalized architecture, which could then fit in HSM or some other secure limits.
I'm going to help here. I think the scoping personally, I'm wondering which hat I put on. So from the progression of this draft,
Yeah.
the framing I think is particularly important. And the reason is that there was quite a bit of confusion with that, with the model and the differences from, the TPM and the familiarity with people in the group from how HSMs are used and the PKCS11 interface, right? So that the hardware, the interface to the hardware, so the PKCS11 is different than with the TPM. I need more coffee, I'm sorry. And so I think the framing is really important just because he is tapping into the PKCS11.
Okay, thank you.
Yeah, and I know Hank has also, and I don't want at the risk of jumping on another landmine, but Hank has also brought up that HSMs don't always have the stack of turtles the way you expect in other types of devices, and so
It is different.
It is different, and so you may have to. And the verifier for this may need to make some assumptions that are different from assumptions you make when verifying other things, and there's a few subtle differences between like an HSM attestation and other types of devices that have keys in them.
You're on.
Yaron Chef, really a clarification question, and I'm new to this draft, apologies. An HSM that's not a CA, do we really expect it to have an ASN1 encoder? Or in other words, is ASN1 the right technology as opposed to possibly smaller stuff like COSI?
Sure. I know lots of TLS servers that run like an Enshield or a Talus and hold thousands of TLS keys in an HSM, and you might want to attest those.
No, that's not my question.
Yeah.
You want to attest keys. My question is whether ASN1 and specifically ASN1 encoding is the right technology for an HSM.
You mean during coding?
You mean
The encoding, yeah. Yeah.
So, okay, so we started this work back in 2022, maybe, and we started it by getting the guys from Enshield and Talus and Udamako and Crypto4a all in the room, and we said, all right, we are the big HSM vendors. We need a way to attest to a CA, and this started with CAB Forum. So this work all started because CAB Forum says if you are going to submit a CSR to a public CA for a Microsoft code signing cert, that key must be in a FIPS level 3 module. That is a CAB Forum baseline. And we said we have no automated way to prove this. And it was like CISOs of like software companies signing letters with photos of data center racks. And look, it says Enshield on the rack. And I was like, this is wild. We surely could do something with software. So that's where this came from. And all the HSM vendors got together and we all said, we're all PKI shops. We're all PKI people. We're devices that speak P11. DARE is the natural language for this consortium of devices.
Okay, thank you.
Can
Somewhat
somebody
you
take
addressed it.
notes?
Sorry?
Both our notes takers are occupied. Can somebody take notes?
So, yeah,
Eckerbot.
No, that's
Okay.
it. Okay.
Usama, please.
Description is not facilitating. I'm highlighting that.
Osama, to you, Dresden. You mentioned that HSM is different from other technologies that we are aware of, like TPM and TEs and so on. in the draft, is there a section which kind of describes for general audience that, hey, this is the actual difference between this, and this is how to interpret this terminology and all that? Is there a section in the draft already which is kind of distinguishing this HSMs to, other than the formats? I'm not talking about the formats itself, but the technology from RAD's perspective. Is there a section which describes that?
Hannes, so we have a fairly lengthy introduction. I forget, it's sort of grown and shrunk over time, but we have a fairly lengthy introduction with pictures and boxes and arrows and stuff that describes this is the architecture of the platform that we're intending.
Section 3 has a lot of terminology, and I believe it addressed what Usama is asking for.
Hank, then Hannes.
Yeah, JP responded to that already. So we went, obviously the document changed a number of times, and we've been bouncing forwards and backwards on how much background description would be needed. We had also that experience with the work in the CSR attestation, and Mike was just talking about the history of all of this. So it's, I think you all have to look into the document to see whether the current text fulfills that need. In the experience we had with the CSR attestation, and some of the authors are here, was we provided a lot of context. And then later on to be told, don't provide that context, and was all ripped out. Like we spent basically like literally 20 pages describing all sorts of context to be later ditched, which is sort of like a very unpleasant experience. So we need to find a fine line here where we don't write the book versus like providing still useful information.
I mean, and maybe that question sort of bounces back to Usama and other working group members, is we're getting close to asking working group last call. Please look at it. If it's not clear, please tell us.
Hi, this is Hank. Please look at it. Also, to reply to...
You're an author?
You should know.
Okay, we have 3
Also
minutes.
replying to Jaron's question, no. ASM1 is not the preferred evidence format in any case, but for CARA-HSM scenarios and PKCS 11, it very much is, and it will never change. So, as the bow die diagram in RFC 9334 tells us, there's a lot of representations, and in this case, it makes a lot of sense. Do we want to be this an example for future things that for evolution are a remote attestation? No. But do we have to do it here? Very much, yes.
Yeah, are we trying to do eat in dare? No.
Yeah. No ASM1 web token.
Usama, are you done?
It's not a joke.
Sam, again, so if you tell precisely which section is it, I think it will be very useful. Like saying that, hey, the big section 3 has something there, so that's not very useful.
Okay.
Okay, so I'm speaking for Carl Wallace, who put into the queue, why TBS like instead of signed data reuse? This was part of the signer identifier comment. And his question is relative to the data model in section 5. If that's just too much detail and you want to answer on list, that's an option too.
Unless JP has a brilliant answer, I don't think I can answer that live.
We could rename it if it lines up better, for sure.
Is that a naming question or a structure question? Yeah, I got to take it offline.
Okay, thank you.
I sit down now.
Yes, next speaker.
Okay. So I get rid of this.
Just make sure I'm not presenting with a coffee mustache. Just make sure I'm not presenting with a coffee mustache.
Oh, well.
And off we go. Okay, so has my time started?
That's wrong. Hang on.
15 seconds.
Is that my clock? It's worse than the
Just start
hackathon.
going so you get an extra 10
Keep
seconds.
going.
Yes,
yeah,
yeah,
I'll get
sure.
to it.
Okay. So hi everyone. This is CoServe. The name of this draft has not changed, and I'm still Paul Howard, so there's no update there either. Is the clicker working? I can't seem to advance the slide.
Yeah. Right now.
Okay, that seems a little better. Thank you very much, Ned. Okay, very quick guide for the uninitiated. This is the RATS architecture, and that is the space in which CoServe plays. CoServe is a conveyance protocol that helps verifiers consume endorsements and reference values from multiple complex supply chain sources. So if you're interested in those particular vectors in the RATS architecture, then CoServe is probably for you. If you are somewhere else in the RATS architecture, then you might be less interested. Why have we done it? We've done it because it's really in recognition of the fact that the idealistic boxes and arrows in the RATS architecture are somewhat betrayed by the real world, and we think there are, a growing number of potential producers and consumers, producers of hardware, firmware, software, or aggregated collections of those things, and also consumers in the form of verifiers that might be online verification services or might just be library code linked into applications. So we think some standardization across the middle there is useful for the industry. CoServe provides a query language. It takes what RATS already has, which is CoRIM, builds very heavily on CoRIM, adds a query language for querying, collecting, and caching that kind of collateral using standard HTTP caching semantics. Right, we get to the meat of it then. So what have we actually done since IETF 125? Well, we have a feature. We have actually extended the query model of CoServe. So CoServe started out life purely based on attester environments. So you would describe an environment in the query, and the CoServe provider would use that environment to deduce the artifacts and the things that it should produce in response. But we figured if we have a query language, then actually sometimes you might just want to do a lightweight query for a RIM document with a specific ID, either a CoRIM ID or a CoMID ID or CoSWID or something like that. So we now have sort of bifurcated the query model. There is still the environment-based model that works just as it did before, but there is now also this alternative RIM identifier based document as well. And the result set structure likewise has a variant to convey just wholesale RIM documents back in response to that kind of query. On the maturity and progression through the working group side of things, we think we are approaching WGLC, but I have some comments on the other side of the slide to talk about that. I do want to say thank you to the chairs for organizing the early review from HTTP Directorate. That is scheduled and I think is due to come in at the end of this month. So there'll be some interesting feedback there that we can take account of, because there's quite a lot of HTTP usage in the draft. So I think that'll be very valuable. We have a fairly small number of open GitHub issues. Some of those are quite nitty, so we'll probably be able to get that number down pretty quickly. Features on the roadmap. So there is some active work actually going on right now. We didn't manage to quite get it to come together for the draft that we brought to this IETF, but we are using the environment-based queries as a way to query for topological information of attesters rather than just the direct reference values and things. So this is basically your, in CoRIM, this is your domain modeling, so domain membership and domain dependency. It would be possible in CoServe to issue a query for that information. So you get the topological information first, and then you can make more targeted queries for the attesting environments within that topology. So that's a feature that we have in flight, and there's open pull request on the draft, but we just haven't quite got it fully together. And into a mergeable state yet. So yeah, on the maturity thing, CoRIM data stabilization, obviously, CoServe is built on CoRIM, so it has to necessarily queue up behind CoRIM in terms of readiness for publication. I think we're somewhat more confident now about the CoRIM data model, but nonetheless, it is something that we have to say, yes, that's ready before we can say CoServe is ready. The slightly bigger issue potentially is the dependency on COTS. That's a common concise trust anchor stores. I will talk about that on the next slide. Open GitHub issues, as I said. I do think at this point, and I guess there's another request to the chairs. Sorry, I'm always coming here with requests. But I think assigning I think it would be prudent at this point to think about assigning a document shepherd, given the size of the
And we were
draft.
just going to ask for volunteers.
We'll do that on list.
We'll do it on the list, but
Sure.
that's what's going to happen.
Oh, okay.
Oh,
Fantastic.
That would be wonderful. Yes, thank you, Yogesh.
Yogesh.
COTS, right? What's COTS? What's the problem? So CoServe at the moment is taking a normative dependency on an expired draft. That's the trust anchor stores draft. So the CDDL model for CoServe pulled out this fragment of it here. One of the things you can query through CoServe is for trust anchors. And trust anchors can take the form of attestation key triples coming from CoRIM. But we have an alternative structure for trust anchors, which is based on COTS statements from the trust anchor stores draft. And you can see here that the CDDL hits a kind of red signal at the point where it tries to import COTS, because that's coming from an expired draft. And we need an answer to this problem, right? So we have various options that we've discussed among the editor team, but we have not yet discussed on the list. I think what we will be doing next is just bringing that conversation to the list. We could look at just removing that dependency entirely and saying that trust anchors can only be attestation key triples, or we can find a way to abstract it so that the dependency is not direct, or we could do something else. And we'll fire off a discussion on the list to try to reach a conclusion on that. Okay, so running code, I would say evolutionary rather than revolutionary this time around in terms of running code updates. But we do have CoServe libraries just for parsing and manipulating CoServe objects, and those are available in both Go and Rust. They're all part of the Verizon community project. And basically, we've updated both of those to the latest draft. So crucially, that includes the shift of the data model to support the two different query types, so that the environment-based queries and the RIM-based queries, those are now both fully catered for in the Go and Rust libraries. So that's a healthy update. Running code updates end to end. So we have this great end-to-end sort of validating proof of concept that we've been building with others in the Verizon community. We brought that to the last IETF. I just want to remind people that it does still exist. It does a full evidence gathering, CoServe query, CoServe result, evidence verification flow. So it is quite validating as a piece of work. There's a repo for it, which is there. Again, the update is more evolutionary than revolutionary. We've basically been revising and respinning components to take account of various small scattered breaking changes that have occurred throughout the stack. The latest CoRIM draft, the latest. This uses ARM CCA, so there are CCA profiles for evidence and for endorsements, and those have been updated. So it was really just a case of lifting all the boats and bringing everything back up to a working state. So what we haven't done yet in this draft, I did look at it in the hackathon. It would be nice to demonstrate the RIM-based query model in this end-to-end flow as well. I definitely have an ambition to do that. I waved around it a little bit at the hackathon, but all I managed to do was gather some observations of, here are some things that need to happen in order to support that. Wasn't able to actually demonstrate it in the hackathon. Some future stuff. So Verizon community is pushing ahead in terms of implementing CoServe for various use cases. This one's quite an interesting one because it's a little bit sideways. It's not so much using CoServe as a query language, but more using it to control things. So in Verizon, there's an endorsement provisioning API where you can submit co-rims. What has been proposed, and I don't know whether it's been implemented yet. Yogesh, can you remind me? Has this been implemented yet? The activate and deactivate based on CoServe queries. I can't actually remember. Okay. So might already have been implemented, but the idea here is that you're using CoServe not to query for resources, but instead to identify resources and activate them and deactivate them. So you know, if you have like a firmware update sort of scenario, you can deactivate an old RIM, you can activate a new RIM, and you can do that based on CoServe queries. So that's an interesting, new, somewhat unanticipated, but perfectly valid use case for CoServe.
4 minutes.
Thank you. Linking Verizon in multiple roles. This one has not been implemented yet, but definitely has been proposed. Go to the issue to read more about this. This is about being able to instantiate Verizon both as an endorsement distributor and as a verification service, and using CoServe, demonstrating how CoServe can be used to synchronize endorsements and reference values between those two very different deployments in a RATS-like architecture. Thanks, as always, to all of these people. The collaboration has been very, very fruitful, very rewarding, and lots of fun. I'm very, very grateful to these people who help build all the things I'm talking about, and also I'm grateful actually to everybody who engages with CoServe on in any capacity at all. We're very, very grateful for the feedback always. Some resources there, the draft, the GitHub repo, and a couple of recent presentations I've done on the CCC attestation SIG, and also in the OCP security working group. And that's me done.
We have 2.5 minutes. Osama?
Sama, I have long-standing concerns on this, and somehow, due to some reason, they are always skipped over, and I don't understand why that is the case. Like, the aggregator itself as an entity is still not clear to me why that is there. I asked for a justification for that, and I don't see from this presentation why or how that is addressed actually. And specifically, what I want to raise concern is that if that entity is malicious, it breaks the whole security argument for the whole RAD system. Do you agree with this before we go into like move next? So if aggregator is malicious, it breaks the whole security argument. Do you agree or do you disagree with this?
I think I disagree with that as a statement. If we are treating of the draft,
And we only have 1.5 minutes.
in this group, we are treating of the draft, not of any implementation or deployment. And what CoServe says about aggregation, there is no evasion on this point. I mean, CoServe does not introduce aggregators. It simply recognizes that they may exist. And it's a transparency play, actually. It's just giving you a way to explicitly describe a process that may happen anyway, implicitly. So CoServe is not introducing or sort of dictating what a deployment looks like.
I'll take a chair action to read the draft, read your comment, and settle this.
Thank you.
Thank you.
I think we're done. Okay, thank you very much.
All right, up next. Yogesh.
You can say share the slides next.
Hang on.
Hello and welcome everyone. I hope you are enjoying the session. Today I'm going to talk about Corim, but just for the newcomers who might be here, I think Paul briefly touched upon Corim. Basically, Corim stands for Concise Reference Integrity Manifest. It's a data format for supplying reference values and endorsements to an attestation verifier performing the job of remote attestation. So it's fundamental for the operation of remote attestation. Next slide, please.
Clicker.
Oh, here's your clicker. Yeah, no, thank you.
So here I'm just describing a snapshot of progress from the previous IETF. As probably who are following the previous IETFs, we had requested chairs for a lot of reviews, HTTPS directorate review, security review, art reviews, and many reviews. So thank you all in the community who have reviewed the document and provided valuable feedback. And we have been very busy incorporating the feedback. And as part of that review, we have done major restructuring of the Corim document. We have folded sections 8 and 9. This doesn't make any sense if I say that. Just to highlight, section 8 was describing the various phases of appraisal, while section 9 detailed about reference verifier implementation. So we just folded that to make the context more meaningful. Then we applied generic condition addition patterns to the environment claims tuple ECTs. What I mean is that you basically break down the external triples into condition addition pattern so that they are easy for a common approach of match and augment. And then instead of terse ProcedureS, we added pseudocode for internal transformation of the reference, the triples, all the triples, as well as the Corim processing algorithm now has pseudocode instead of language. And we consolidated introduction section so as to have a very high level context of what is been going on in the reference verifier algorithm section, so as to make the readers more understandable of what is going to come next in the subsequent sections about the reference verifier. And of course, general tidy up and minor improvements were performed to make it look more neat. So, okay, next slide, please.
Clicker.
Clicker. It's in your
Sorry,
hands. It's okay.
So,
It's early.
as I mentioned, I'm just going to reiterate that restructuring helped us a lot to incorporate the feedback, and the document now is much more consistent because it follows a unified approach of match and augment, whether you're processing any kind of triple, whether it is reference value, endorsed value, conditional endorsed value. All these triples follow a common match and augment algorithm. And of course, when transforming the terse text to pseudocode, we realized that a lot of common pseudocode can be abstracted into functions which can be reused from multiple places, thus removing a lot of duplication, thus reducing the document size and helps improve the readability of the overall document. And this also helped a lot in when we split the triples into condition addition pairing, as I mentioned in the internal representation, that simplified the processing algorithms very much as well. And so we believe that with doing such a big exercise, and thanks to Thomas Fossati for starting the heavy lifting on this, and my co-authors, Ned and Hank, and me kind of chipping in, and I hope we have done a good job. And I would hope that this would incorporate all the review comments which have broadly been implemented now in the document. So I'm going to delve a bit deeper into the restructuring because I believe that Corim is becoming extremely popular, and it is our job to help understand the Corim to the entire community. So I'm just trying to go through a bit in detail about this. Just to let you know that this high-level flow is not been updated since the last IETF, but this just sets the context for the subsequent slides, where you see the external reference values and endorsements generated as Corim files submitted to a RATS verifier, and internal to the RATS verifier is the Corim processor. I'm going to go into deep of these blocks, so I'm just going to skip to the next slide so that I can focus. Now the green box highlighted on the right is the stuff which I'm explaining on the pseudocode on the left, where we do the validation and internal representation and transformation of the external triples into an internal representation, where the external triple is broken down into, as I mentioned, condition, addition, ECTs. All the triples X here represents any triple is transformed into an internal representation with has conditions and additions. I'm not going to delve down deeper further because of a limited amount of time. I'm conscious of time, but I'm happy if someone approaches me later down to understand the algorithms in a deeper flow, and I'm more than happy to spend more time with them. So after the internal representation of the triples, I'm going to explain how the evidence gets transformed. Just to be clear, evidence transformation is clearly out of the scope, but here we are just explaining it in a very high level so that it makes sense, because evidence is where the appraisal processing starts. So the evidence is also validated and it's transformed into ECTs. And this is an algorithm to show that the evidence claims are how the evidence claims get into the ECT structure of the ACS. And this is just an initialization slide where when the appraisal starts, the triples internal representations are loaded into the ACS. Is loaded into the staging area initialization stage. At this on the left is the staging area initialization, and the evidence goes into the ACS directly because you start the appraisal with the evidence. And this is the kind of core meat of the algorithm, where each time you load a triple from its internal representation from the staging area, you match it with the whatever is in the ACS. So at start it is matched with evidence, and once the condition from the staging area ECT is matched with the ACS, if it is satisfied, you may want to perform some additional checks for consistency in the ACS before subsequently adding the ECT into the ACS. And this is a generic architecture of match and augment. This is applied to all triples, whether it is reference value, endorse value, or domain dependency or domain membership triples. And then subsequently, after the match and augment is complete, you hand over the ACS for subsequent processing. Subsequent processing could be applying appraisal policy for evidence as one stage, or adding verifier added claims, or transforming the ACS into an external representation for attestation results. These are clearly out of scope for the document, but this is explained here for the sake of completeness so that the reader gets the overall picture of how the entire end-to-end reference verifier would work. And we had done some general tidy up based on some of the comments, especially like we had a detailed certificate validation paths, but some reviewers highly correctly pointed out that this is just duplication of standards from RFC 5280 for certificate validation. So we kind of now referenced it. We clarified that in the staging area itself, it would be advisable to remove the cyclicity of domain memberships so that the processing becomes much cleaner down the line. And then the locator map in Corim is just an advisory that you can use the locator map, but there is no kind of hard mandate on it must be correct. If it is there, can be used, great. And we had some questions from some of the external users about how to do if a single target environment may have multiple reference state, how to encode that. So we have clarified that the encoding should be in separate reference triples when they have multiple reference states for a single target environment. So next steps, we believe that bulk of the restructuring heavy lifting has addressed almost all the comments which we had. So we request all the reviewers who has reviewed the Corim document to reread again once, quickly sanity check to understand does their comments have been addressed or not. So that feedback would be really appreciated. And post the heavy lifting, tidy up and restructuring, we believe that there are still some minor issues these are some of the top level issues. I'm not going to go into the details of all these issues, but there is still a bit more tidy up to be done before we go to the next stage. And we believe once this tidy up and one final check from all the reviewers is done, we believe we are ready for another working group last call in either the next IETF or just prior to the next IETF. So that would complete the document going into the standards. I think that's the end of my presentation on CORIM. If there are any questions, I'm happy to answer. Okay, then I can give 10 minutes back to the.
Great, we'll take it.
Yeah. We can move on to the next presentation. Okay, now I'm going to talk about one more interesting topic about remote attestation with multiple verifiers. And with me joining is Jun Zhang and Huda from Huawei, with active contribution from Henk. But I must also say that we thank Thomas Fossati from NVIDIA, Gada from Orange, and Thanasis from UBTech, who have been very active contributors and very patient reviewers and contributing to the standards. So thank you so much to all of you. It's a joint presentation from all of us. Oops, why the next slide is not working, the buttons. Can you please?
Yeah, I have to redo the clicker every time.
What happens?
Try it now. Try it.
Yeah, yeah, it works. So today I'm going to talk very briefly. I hope this presentation is also very brief. Today I'm going to talk briefly about the current document status, progress implementation in the open source project Verajon, and discussions and topics that arises because of multi-verifier or composite attestation, overall architecture in general. So multi-verifier draft is now officially adopted as a RATS working group item. So congratulations, well done team. It's an outstanding work resulting in excellent result. I believe this is a very important work for the RATS community, and thank you all who has contributed. And I would like to take this opportunity to thank both the RATS chairs for their leadership and valuable guidance getting it adopted. Thank you so much. So once the draft got officially adopted, me and Henk together, we moved the document into the RATS working group repository. And with the painful efforts, we managed to retain all the commit history, the previous work, GitHub issues, and open pull requests are successfully now moved into this new repository. So this is the new repository. And if you have any issues, concerns, feel free to raise it on this repository from now onwards. Okay, now I'm going to talk in detail about the open source implementation of the multi-verified stuff and composite attestation we are doing within the open source project Verajon. So last 3 months, we're busy implementing some of the attester side of things, the library, because we felt that this is fundamental if we want to do the verifier implementation, because as I will explain you, this composite evidence library generates composite evidence, and the library needs encoding and decoding APIs so that the verifier can also invoke it when it's processing the composite evidence. So we have now a fully working library support for and APIs for setting, validating, and encoding and decoding the lead attester claims. So we have if you see the RATS architecture RFC 9334, you have a composite device which has a lead attester and component attesters together in a composite device. So we have implemented that library for generating token for this composite attester. And so we have a API to set the lead attester claims. And we can set the full composite attester token using a CMW collection. So we have APIs for CBOR encoding and decoding that, as well as we have mechanism to sign the overall token and the verification of that, signature verification of that. So both the APIs, all the APIs of setting individual component attester token, as well as the signature and verification of the complete composite attester token is available now. And now I'm going to the core multi-verified lead verifier implementation, where this is the overall architecture, high-level architecture of this, where you have a REST API to handle the composite evidence with a media type. And then You invoke a parcel table. Parcel table will identify which parcel to invoke, because of course, based on your media type, you could have multiple parsers like CMW collection parser or each submod parser. And then once you invoke the right parser, you get n number of individual component tokens with their media type. And then you invoking the dispatch table at the bottom, you invoke the appropriate clients, and the clients communicate with external verifiers, or internally, if you are implemented within Verizon, any verification like CPU, the client would invoke that. Otherwise, you can contact Intel Trust Authority for remote verification or NVIDIA GPU verification. This is how the multi-verifier functions happen. And on a private branch, we have these elements of the architecture complete, but some of them is still work in progress. And once we complete that, we will do the full integration and then merge the changes to the main branch after review. Okay, so while discussing multi-verifier and composite attestation in the various design meetings, we discovered new and interesting problems, but they are, I must say that these are new challenges, and the new challenges are of discovery. How does verifier discovers other verifiers to complete the composite attestation verification? And of course, discovery can be taken at one level up. You can have multiple endorsement services. How do you discover that? So it's not, I believe that this is not specific to just verifier, but it is beyond the verifier as well. Discovery is a problem, not a problem, but an interesting challenge to solve. So I think we in RATS community should take a look at our discovery at a slightly higher level. Second is the trust establishment. How do verifiers trust each other? If there are n number of verifiers doing the verification, how do they trust each other? Relying party also now needs to trust n verifiers instead of one verifier. So how does we bootstrap that kind of trust establishment for the entire ecosystem? And in the composite attester meeting, another third aspect which we discovered is that the freshness handling. With the single verifier, the verifier or the relying party sends a single challenge to a attester, and it just use that challenge to encode the evidence. But now on the device, you have n number of components. So each of these components may have different challenge requirements. But the relying party or a lead verifier may just send one challenge. So how do you mix and match? How does the nonce adjustment happen? So those kind of challenges we still need to address in the RATS community. And I believe that going forward, we will be addressing that. So the very first discussion on this is in a side meeting, which is organized on Friday, 10 a.m. here in Vienna. I would love to hear your feedback, your ideas, and would be happy to discuss and progress these issues going forward. I would like to ask one thing to the RATS chairs, that as far as the multi-verifier document is concerned, it is in a very stable state. So I would request chairs for the subsequent reviews so that we can take it to the logical conclusion and go for working group last call after the reviews. So my humble request to the chairs, if they can organize all the reviews required to take it to the next stage.
Okay, can we get some volunteers for reviews? Hannes, Michael,
Yaron,
Paul,
Howard,
thank you.
Mark Nowak.
Thank you. I need more coffee. Anyone else? Okay, I'll also aim to review it.
Oh, thank you so much.
Anyone else? Anyone in the anyone remote would like to review as well? Just put your name in the chat and we'll make a record of that. Much appreciated. Thanks for your work.
Thank you.
We do have a queue. Hank
yes.
is up first.
Yeah, hi, this is, there's more than one. Yeah, hi, this is Hank. I just want to highlight that these challenges will not scope into the document.
Yeah.
These are adjacent issues, and we also will not do a zero context discovery like a Dawn. Sorry. And so this has to be more specific to the RATS ecosystem, maybe some context-specific discovery, maybe some context-specific decision-making and trust establishment. There are existing building blocks, of course, and Michael will elaborate on that, I assume. And but But this is very important to highlight that this is not part of the existing document. It will be an incubator for future work.
Okay, we only have just over a minute, so please make it brief.
We have 10 minutes from the last week.
Yeah,
Oh, we have 10 minutes. Okay.
So I've
Thank
already
Yes, Usama.
Well, I
I've
was
already
watching
given
the
my
counter.
review, so there is no need to give a second review. So the comments are unaddressed. If you go back to the slide, which was new challenges.
Yeah, Usama, just to clarify that,
So
we have already identified what you have raised here. and
Right.
that needs a broader discussion as a separate discussion from the multi-verifier document. So I think Henk was very clear to say that we are not going to scope creep. You had a concern about the trust establishment of relying party to n verifiers versus one. If I'm not mistaken, that was your concern. And I think I've precisely listed this to be addressed as a new challenge outside of the multi-verifier document. I
Right,
wanted
but-
to advance clarify that before you kind of bank on the same question again.
So what I'm saying is that saying this in the meeting is fine, having it in the slides is fine, but is it acknowledged in the draft itself that this is a problem in the security considerations or not?
I don't think this needs to be explicitly stated there.
I disagree.
At the top level, we have said that this increases some of the security because of multi-verifier may increase security in certain situations. That's all we have acknowledged that. Yeah.
So my comment
Yes,
is
Mark.
not specifically on this draft, but
Yeah.
as we look at things like location verification
Yes.
and I think a device with location sensor should be a composite attester,
Yeah.
and they should snap together. I'm looking forward to seeing that. I
Absolutely.
haven't seen it yet. Maybe I'm just not reading it. Right.
I think, Mark, it's a very valid point and a valid concern. What I believe is location sensor can have its own attestation, and we can aggregate this attestation as part of the composite attestation, and we must do that. Perhaps, yeah, I think maybe we can create a new draft for addressing how the location incorporates as a claim in the composite attestation story. And I would love to see a new draft specifically for geography, because as the workloads get deployed in different parts of the world, there are some governance or legislative requirements of workload not moving outside a specific geographical zone. And I believe we need to have a new separate draft for that. Yeah, and then we should use some of the work from here and reference in the new draft that how the composites needs to be constructed. And let's work on that. And I think I fully acknowledge that we should do some work on this. Yeah.
Yesterday, there was a BOF on discovery, which is aiming
Yes.
towards sort of a generalized discovery mechanism for the internet. What do you think is the right way to position this
Yeah.
bullet point?
I
relative?
I attended the BOF to completion. And initially I thought that their term entity was much more generic to say that entities could be nodes. But later I realized that in their agenda, they realized that it could be a lot of scope creep in their BOF. So they defined the entity as a narrow AI agent to start with, if I am not mistaken.
Yes.
So then I realized that because they are only in scoping they're narrowing their scope to entities as AI agents. I think we should create a new discussion within the RATS community on discovery, and we should address within the RATS for our attestation requirements for discovery, whether it is for endorsement services or for multi-verifiers or any discovery of attestation specific nodes. That's my view, but this is purely my personal view. Yeah.
Okay, so I'd say any work on that will have to take in context existing methods, right? So that if we don't have to create something new, we're not.
Yeah.
Thank you.
Absolutely. Yeah. Thank you so much. Ned, you have your hands up.
I'm happy.
Okay. I saw you in the queue as well. So.
Yeah. So hi, this is Henk again. Zero context discovery, which I think Dawn still is interesting. There was a nice comment. I forgot who said it, like zero context discovery on the internet is impossible. Context-specific discovery in an authority or in a certain domain is solved. What are we doing here? So that was one Dawn comment. At the end, Eric was pretty, as one of our IDs, was pretty happy with the result of Dawn. I just have to say that it does not seem to apply here. Named entity discovery is something we do. So under that catchphrase, I think, yes, we are in the scope of Dawn. And I think the scope of Dawn will change drastically. Also, the assumption that there will be about agents is premature. So yes, so all of these things happen. And I think we should not be dependent on that. We should just go on. We have a certain discovery mechanism there, and so on.
Absolutely. If we wait for Dawn to, and they may say, okay, sorry, this is getting too much. We are, any generic nodes are out of scope, and then we will left out. So that's why I said that we should start discussing within RATS working group. Yeah.
So about the discovery point, is there something that's maybe building up on this Hank's comments? What is really specific to RATS in this? Do you know exactly? Like
Yes.
compared to Dawn, is there something really, really specific to RATS or
Yes,
something
absolutely.
distinguishing?
Absolutely. Because as you see, discovery needs the right capabilities. But when you are using the word capability, it has a specific meaning in the attestation ecosystem. When I'm discovering verifiers, right? The capability is what type of attesters I can verify. When I'm talking about endorsement provisioning, endorsement distribution services, what type of endorsements I keep. When I talk about endorsements, it could be a generic term, but in specific meaning in RATS ecosystem, the endorsements have a very specific meaning, reference values and endorsements. So when I'm discovering that, the capabilities differ whether it is an AI agent node discovery against the discovery of a node which is specific to RATS. Yeah. So capabilities drive that kind of discovery. Yeah.
So like endorsements and reference values, which you are saying that they are different from Dawn.
Yes.
That's a specific artifact that we have in RATS. I still don't see what is like in general terms from Dawn. If they do a capability for, let's say, doing something X, we have here X is equal to endorsement, X is equal to reference values, or X is equal to, it can verify that something. So that to me is still a capability. So I'm looking at some fundamental difference, which I still do not see. Okay. Is there a real fundamental difference in what they are planning to do might change?
You can club it all these things into one umbrella. I'm not saying that is not possible, but they will not do it because for them it is a scope creep. Yeah, they will say, why should I discover attestation nodes in my AI agent discovery, right? They will. So my point is, you can always club with them, but they should be willing to club, right? If their scope is very narrow, then we will be left out, right? That's what I'm saying. Yeah.
Right. I mean, we could utilize it.
Yeah.
So I think CoServe is a form of discovery as well.
Yes.
Should I unmute from Huawei? I have a...
Can you please bring down the mic? It's not audible here. Or you can just pull it up.
Okay. Thank you, Sema. Okay, just to give a comment, because I attended also the Dawn booth yesterday. At the conclusion, at the end, the Dawn chair was thinking that they will narrow the scope of Dawn to be focused on AI agent.
Exactly.
So I think in this time, during this period, transition period, it's good to continue to work on RATS working group on this specific issue, and we will see.
100%, I agree with you, Huda. Yeah.
Yeah, this is saying basically the same thing. So we are putting conjecture on something that is not there yet. So just don't.
Okay, I would like to give 1 minute back to you.
Okay,
thank you. Cheers. Yeah.
Looks good now.
Hello, I'm Ken Takayama. Today I'd like to share a short hackathon report about remote attestation in TIP provisioning use case. Next slide, please.
Oh, that's
I got it.
obvious.
Oh.
Thank you.
We can't do
Okay,
that.
yeah. Okay, yeah. So TIP is an IETF protocol for provisioning application into TEs, and it can carry remote attestation. At the same time, it does not define each appraisal step in detail. To get implementation experiments with how remote attestation work in TIP, we implemented a term that uses evidence for provisioning. In RAS terms, the term is the relying party in this use case because it uses the attestation result to decide whether to provision an application to the device. In our hackathon implementation, our term also included verify-like functionality. So that's why I said our term consumes the evidence. More concretely, our term directly verifies inter-SGX quote evidence from the attester before making a provisioning decision. By implementing those appraisal sets in one term, we were able to identify a possible boundary between reusable evidence appraisal and TIP-specific appraisal. In other words, between verified appraisal and relying party appraisal. Next slide, please. Okay, yeah. So the basic flow is as follows. First, the TAM acting as a relying party sends a nonce to the attester, which is T-enabled device. The TIP agent running inside the TE generates evidence. In our implementation, this evidence is inter-SGX quote that binds the nonce together with an agent public key. The attester sends the evidence back to the TAM, and our TAM verifies the evidence directory before processing with provisioning. Next slide, please. Here, I have listed the kinds of checks that appeared in our TAM implementation. Some are about validity of evidence itself, and others are about whether its claims are acceptable in the TIP context. Next slide, please. I think we can now see a possible boundary responsibility split. The checks on the left look closer to verify-like appraisal of evidence itself. The checks on the right look closer to TAM as a relying party interprets those claims for provisioning. So the observation from the hackathon is that these different responsibilities ended up together in our TAM implementation. For maintainability and reuse, the generic part may be suitable for verifier component, while the final provisioning decision remains with the TAM. Next slide, please. We have started discussions with this direction with members of the Verizon project. Verizon may be used not only in TIP, but also in other remote attestation contexts. For example, use cases discussed around attested TRS in the seat working group. For that reason, we think it is important to continue discussing what should be verified by a generic verifier framework and what should remain specific to each relying party or protocol use case. We would be happy to contribute to Verizon community, and I would like to also very glad to hear any comments or questions from this working group. Thank you.
Sama, please be brief. We have less than a minute for both questions.
Yeah, I will be very brief. So the binder that you have used with the nonce and the public key, that's already proven to be wrong. And there is a CV already with a score of 7.5. So you might like to have a look at the resources I have put in the chat. Thanks.
Okay, thank you. Yeah, I'll be careful.
I have no question. I would just want to welcome you to Project Verizon. That's what I was saying. So welcome.
Yeah, thank
Okay,
you.
thank you so much for your presentation and your work.
Hello,
Hello?
can you hear me well?
Yeah, we can hear you.
Thank you. Hi everyone. I'm presenting draft Poirier RATS ETDA, which is an EAT profile for trustworthy device assignment. I will tell you what trustworthy device assignment is in the next slide. This is joint work with Mathieu and Henk, and I am presenting in lieu of Mathieu. Next, please. Right, so the context, the setting is confidential computing with device assignment. So you have a NIC, you have a GPU or a disk that gets pulled into the confidential VM trust boundary. And the question is, can you trust the device? And the answer is, of course, not until it gives you evidence about its identity and state. And that's the gap that this draft closes. Next, please. All right, and to be clear about scope, we are not inventing anything new here, no new device attestation protocol or whatever. We're just doing some sort of, we're homogenizing device evidence around it. The problem is that buses speak their own native formats, be it SPDM, CXL, CHI, and so on. But what we would like as RATS is that verifiers and relying party all converge on a common vocabulary and all speak it, right? So this DAT, this device attestation token, which we propose, is the translation layer that sits between native bus artifacts and standardized IT claims. So you can think of it the way IP sits above many different link layers, and you have one convergence point and many formats that that live underneath and can be plugged, right? An interesting bit here is to notice that there's also parallel momentum on a Linux kernel ABI for retrieving this device evidence based on netlink sockets, which is encouraging for real deployability, and we're using in our prototyping work. Next, please. So yeah, there's a question that we got. So why do this now instead of waiting for devices to go and speak it natively? And because SPDM 1.4 has introduced this capability, but our observation is that in the same server, even in a bright future when SPDM 1.4 is well established, yes, you can have a device that speaks it natively, but alongside that, you will have an older SPDM device that can't, a legacy PCI hardware with absolutely no SPDM support, and on top of that, you could have buses whose EAT conversion story is not yet written. So as IETF, we don't get to dictate what DMTF, PCI SIG, and other SDO standardize at the bus level. What we can do, though, is define how their outputs can converge into RAS evidence. And critically, what we think is that this heterogeneity is not a transition period that we're waiting out. It's going to be the permanent state of affairs. Next, please. So this is the system model. Here's the model we're dealing with. You have a confidential VM with one or more assigned devices inside its TCB. And inside the confidential VM, there's a lead attester, itself measured as part of the platform evidence. And the thing that is being appraised here is the composite evidence, not devices in isolation. And on the other side of this big box, you have an external verifier or relying party that consumes this standardized it. And in the system that we are dealing with, the lead attester can play one of two roles. It could be a pure forwarder and just translate the native artifacts that it received from the bus and pass it through unchanged, or it can be a lightweight internal, let's say, verifier that checks device identity locally, and then based on the success of the operation, repackages the result as claimed. Okay, next, please. So here's the CDDL for the DAT. What is in concrete terms? It's an EAT profile for device claims, right? This is the highlight. And you can see the shape here. You have an EAT profile that identifies that this is a DAT. You have an EAT nonce for freshness, and then you have these submods, which is a map from a namespace qualified name to a device claim set. And this is the very simple framework we designed. It is deliberately extensible. We are defining SPDM and PCIe legacy for older hardware, but there's room for other buses in the future. And in section 5 of the draft, we have the rules for adding the other buses. One thing to note, it's not encoded in here, but that each submod carries, it's an EAT in itself, so it carries its own EAT profile. So both the bus technology and the version of the bus technology are explicit at that granularity, right? So we can evolve the two things. Another thing to note is that the DAT can stand alone or can be embedded inside a larger composite evidence message, as we see in LASD. Good. Next, please. Right. So okay. So this is taken verbatim from Appendix B of the draft, and there's a picture that explains a composite attester provided by Verizon RATSD that incorporates, crucially, that evidence in the larger composite evidence. From left to right, you see the challenger's node that goes to the lead verifier through a standardized API, and then the lead attester broadcasts the nonce to the sub-attesters and collects platform evidence and device artifacts via that guest kernel API that I mentioned earlier. And what it does, it translates the native device outputs into that submods. So here you see SPDM-A, legacy PCI-B, SPDM-C as example submods name. But later I will what the convention is exactly. It then assembles everything into a single signed CMW collection, and alongside that, it puts into the collection also the lead attester's own evidence and the platform evidence. And this is the aggregate that is then signed, and the nonce broadcast to this individual sub-attester creates basically the binding that provides internal coherence of the whole assembly. The verifier then receives one composite message, breaks it down into the constituent pieces, and handles the appraisal, maybe locally, maybe dispatching to sub-verifiers, as was presented in the multi-verifier presentation before. Next, please. So zooming in to the actual translations, we have SPDM measurements, certs, challenge transcripts, TDS reports. All of them map to registered EAT claims provided by the SPDM claim set. We also have PCIe legacy config space data that map to a dedicated PCIe legacy claim set. And we allow future buses like CXL, CHI, whatever comes next, to get their own claim set plus that according to the naming rules in section 5. So the point of translation is that someone has to understand what the bus actually said, and this is the lead verifier or the plugins that talk to the lead verifier associated with each individual sub-attester, but the verifier shouldn't have to, and this is the simplification that we're, the value proposition here. One thing to note is the translation that we are proposing is purely syntactic. There's no semantics introduced at that level. For example, we have for different SPDM measurement component type, we define aliases, but this is only about syntactic expressiveness. There's no extra semantic on top of that. Next, please. Yeah, so let's pair the verifier. So the idea is that most verifier only need device identity and state in EAT form, and that's it. We allow for full bus protocol artifacts like challenge transcripts, VCA, TDS reports, and so on and so forth to stay available, but they are optional. They are only for advanced verifiers that really need to consume these kind of things. Otherwise, they are erased and only the crucial information is transmitted. Next, please. Right, so this is probably the main value beyond pure syntax conversion. Submod names follow a convention. For example, for SPDM, we have vendor class instance. So Acme vendor widget class 012 blah, blah, 9, the instance identifier. that are derived from the leaf certificate SUN. And that name lets a receiver derive a quorum environment directly. And from that, look up the matching reference value and endorsement and whatnot for that exact device. So naming here is not cosmetic. It's an evidence to reference state, endorse state linkage primitive. So here's there's overlap with quorum, and a quorum profile for this is anticipated, but it's a separate future work, is not inside this this draft. Next, please. Okay, I think we can skip over this. This was addressing a comment from MCR and Jonas we got on list. Next, please. What is standardized? So yeah. So concretely, what we have in -10, we have the framework itself, including the outer wrapper, the extensible device claim set socket, and the extension rules in section 5, which include the requirements around naming conventions for submods and something else I forgot. Anyway, and then we have concretely 2 claim sets. We define one for SPDM, including measurements, certificates, optional challenge, VCA, TDIS prep port, and one for PCIe legacy with minimal config-based claims for these non-SPDM devices. And alongside that, of course, the corresponding IANA registration requests. And what is out of scope for now, since Giri asked, I don't remember whether on the mailing list or in a GitHub issue, we are scoping out live migration and on-chip SPDM. That said, the framework is built to evolve with both bus technology and protocol version for a specific bus technology. So this is not meant to be exhaustive bus coverage on day one. In the future, people might add their own thing. Next, please. Okay, we can skip this. Thank you. Quick recap. So 4 things to take away. A, deployments are heterogeneous in terms of devices they incorporate, and realistically, we think will stay that way. We take a pessimistic view, but I think that's fair. Second, that what that gives us is a stable, right, IT-based convergence layer for device assignment. Third point, we have explicit submod naming rules to bridge smoothly to quorum environments. And fourth, that the framework is extensible, and we don't need to reopen the core model to add new stuff in it. Which brings me to the ask. Next, please. We think this is ready. We have worked hard on this in the past 12 months, and we'd like the working group to adopt it. Thank you very much. And thanks very much to reviewer Giri, Carl, Jonas, Yogesh, MCR, Ned for the great feedback that made this version is super improvement over 09. That's it.
That's it. Nobody's on the queue. We have a couple of minutes.
Can you summarize in 2 sentences the problem that you are trying to solve at a high level? Like, I see that you are trying to define a format. At a high level, can you say very briefly, like, what is the problem that this will solve from adoption perspective?
Yeah, so I think the problem we are solving is the homogenization. And it was in slide 3, I think. So you have all the buses that speak their own formats, and you have verifiers that want to that don't want to know about all those formats, that only want to know about state and identity of the devices that were attached to the TCB of a confidential VM.
It's
And
just
this-
transformation.
So can I say that basically you're trying to, so there are devices with different formats, and you are trying to uniformize that in some sense, then that the verifier needs to understand only one format, and that will be a transformation of all of these formats to that. Is it?
Sort of, yes.
Okay, there is a disagreement within the office.
So the point is that this is a device, and the device is a composite of parts that are, for example, a confidential compute component. You have a part of a CPU, you have a part of a bus, you have a part of a tensor accelerator, and all these things have to be associated in your group to form your confidential enclave. And these parts that are not devices, well, effectively you can call them devices, but we would prefer components. They speak different languages, but the verifier won't get that. So that's the translation. Okay, you can say that, but the verifier, and it said some of the slides say this, the verifier cannot be mandated to understand all these dialects of these components. That is why the debt exists. Thomas, could you clarify this as a yes or no?
Yeah, but I think that was Usama's point, isn't it?
Yeah, I mean, this is not an uncommon problem to run into, right? We're not the first to do this type of translation, transformation, whatever you want to call it.
Absolutely.
Okay, we're out of time.
Okay, any action from the chairs?
Why don't we gauge interest?
Yeah, interest.
How many people have, we'll ask how many people have read the draft?
Are you typing in the question?
I am.
No. Someone did that actually.
Oh, sorry. I mean, we can reflect in the minutes. Well, yeah.
Kind of over time. Maybe we want to take it to the list.
Yeah, we'll finish this quickly. So okay, 5 so far, have 6. So we have a good number of people who have read the draft. Well, we can take the rest of the questions to the list.
We had 6 reviewers on list.
Yep, so that's pretty good. So let me see if I end this, and then we see what is the interest in adopting, and obviously a formal adoption would have to be big enough, and we may need more reviewers. Okay, so just do this super quick, and then we'll take it to the list. What is the interest in adopting this work? And this isn't binding. Everything goes to the list. So, okay, good. I mean, it's pretty straightforward, the concept, right? So I don't think it's foreign. Okay, so it's a pretty good showing. Give it one more. All right, so we have at least 13 people interested. And so we'll take it to the list to confirm. And
Thank you.
Yeah, and we'll progress other work because we do have to make sure that happens.
I just one comment I have. I think Thomas, correct me if I'm wrong, but did we mention that we have commitment to implement this in Verizon?
Yes, I talked briefly about prototyping, and yeah.
Okay, wonderful. Thank you.
Yes, and the Linux kernel also. Yeah.
Oh, great. So 2. Okay, excellent.
Bye-bye.
Michael, are you presenting?
Hi, my name is Michael. If I'm too quiet, let me know. My voice is broken. finally found a way to shut me up. This is a collection of a few different documents about geographic geofencing, location, proof of location, and results. Next slide, please. I apologize for the.
Oh, sorry.
I can click it if you want.
Thank you. Apologize for the wall of text. I would have liked to change it to some diagrams, but there wasn't time. So a lot of entities, a lot of things need some kind of a proof of environment at some level of where they are, what jurisdiction they're in, what building they're in, whether they're connected to green energy, a whole bunch of different things like that. There are many different ways of getting those results, some of which are hard, some of which are easy, some of which are insecure, some of which are good enough for the purposes of the person who is the relying party. So the goal is at no point to argue about how, please never argue about whether GPS is spoofable. We all know that. But like all attack and risk benefits, you have to ask how much does it cost an attacker to attack me doing this, and do I care? And in some cases you do care, and that's an unacceptable risk, and in other cases it's an acceptable risk, and there are many, many different ways of doing this. So don't get hung up on one particular thing. So this is the goal here for this. And so the idea is that we're trying to put together the what and the where, and we're trying to express this into a common set of results. So a number of different variety of inputs, essentially different kinds of evidence go into different kinds of verifiers. Verifier produces a consistent and easily evaluatable result. There's a lot of different pieces that can go into that. So since 125, the documents have gone through a couple of revisions, and there's been some interactions with some other entities, including the Sovereign Cert Group, and a lot of different things. There's a number of different activities, involvements, and there's still a potential, for instance, interaction with the NTP working group, specifically for things where it's good enough to know that you are within some number of meters as measured by speed of light of the electrons in the fiber. And to do that, you need good time signatures, and NTP is doing that. So that's, for instance, speed of light, RGT, proof of jurisdiction. So those are the different things, and the idea is that we would have a number of different documents that would produce evidence, explain how that evidence could be verified, and the risks and benefits or security considerations of those methods. So some of those documents need to come to this working group, and some of those documents ideally would be elsewhere in other working groups. WMSI has, I would say, schizophrenic interest in some of these things, and I don't think it fits quite in their charter at this point.
Agreed.
So one document is this geographic results document that basically says, once you've done all the evaluation, here's a common format to put the results in. With, I would say, the most complicated part is the fact that you really do have to deal with potentially with exclaves of jurisdictions, and there's some good videos about weirdnesses at the Belgian-Dutch border of enclaves inside enclaves inside exclaves inside exclaves inside exclaves. It's very bizarre, but that may matter to certain entities about where exactly they are. So we're looking at the verifiable geofence as looking to come to RATs. The geographic results is a separate document that encodes into ER, and the VPA verifier, I would say, is still needs to be more clearly articulated as to where it's going to belong. But I think probably this is going to be the default location. That's really it. I think that was the last slide. Yeah. No questions. Everything's crystal clear.
not a question. It was crystal clear, as you said. So thanks. I would like to raise support for this. That's a real problem. And we have shown that also in our research that basically the evidence from generated from any part of the world can be accepted by the verifier. And that's really a real problem, because then one has to trust the whole world that all the TEs in the whole world are secure in order to be secure. And I think this is a real problem and we have to tackle it. I don't have a specific opinion on this specific draft, but as a whole, I think RATS should adopt something. And there my question maybe is that, how does this specific draft relate to, I mean, there were 4 drafts. So have you, by yourself and with discussion with all the 4, have you settled down on this as the way forward, or is it still ongoing between the authors of all the 4 drafts who were looking into the location? And we
That's
also
why I wanted
have
a picture. That's why I wanted to do a picture, and I didn't have a, I didn't have the time to do that. But yes, essentially, I would say that we have reached, after I would say we have stepped back and said, is the architecture that we had, say, in Montreal, we envisioned, is this really the correct architecture? We stepped back, and I think would say, having stepped forward again, the answer is yes. We can't think of another way to organize it. So yes, there is a results, and there are ways of getting to that results. The results document is a separate document, and then there are, we can argue about how many, but there are between 2 and 3 ways of producing evidence to that result. The ways of evaluating that evidence, to the extent that it needs to be standardized, would be in that document. So the descriptions of the verifier activity would be in that document. The output of the verifier would be in the geographic results, the common document, which really doesn't say much more than, I would say it's a little bit more than syntactic, but it's, you know, there's the fields have semantics, but exactly how you determine that you are in the embassy of Taiwan in downtown San Francisco is irrelevant. What matters is that you are subject to, you are in Taiwanese jurisdiction, and that's what the important part is from a relying party point of view, right? That's what matters. So there, as it could be two or three documents. I think one will wind up in NTP ultimately, and the other 2 will wind up here. They could be combined. I think that's open to, that's fungible. The working group would decide whether it prefers bigger, longer documents or smaller, sweeter documents. Clearly, the IETF has poor track record at both extremes. So big documents take longer, many small documents take too much people. So what is the right, you know, that's up to the working group to decide, I would say.
So we will
but
be
I would
happy,
say no
like,
more than 3,
yeah.
but probably more than 1.
Yeah, Camilo and I will be happy to collaborate either way. Like in our draft, we can also merge it with this one or whatever, or keep it separate.
I would
That
say
would
like
be nice.
there's like potentially 27 different ways of producing evidence, and it may not benefit anyone to mix the text together. But on the other hand, the motivation and whatever, if someone says, okay, no, I want to put the motivation for the why in one place, and then I want to have the smallest possible text just to explain how that makes sense to me.
Okay, 40 seconds.
Okay, my question is that can the attester has the right to control the granularity of the location evidence, so that because you can the scale can be one city, one country, one specific carrier.
You're asking a question specific about the
Yeah.
evidence to results
Yeah.
process. And that's why I think there's more than one way of getting there that results in the same thing. The attester could be very, I don't know what the right word is, verbose about where it is, but the verifier may say, but I don't pass that information through.
I think this is related to the draft proposed by Mike, the privacy framework. I'm stuck here.
Yeah. But there's 2 ways of thinking it. The attester can just not say what his street number is, but the verifier could also say, I don't pass on the street number. for example. But now you have to trust the verifier to filter your information. But then I think that is an ongoing negotiation. Thanks.
Okay, thank you for the presentation. My questions, so I had a couple of questions, but I'd like to follow up after because we're out of time.
Okay, good.
The questions are, there was technical problems raised on this at the last meeting. So I'd like to have a conversation and understand how those are addressed on geofencing. No, on geofencing, there was a technical consideration. I don't remember if it was Dave Thaler that raised it or Lawrence Lundblade. I believe it was one of those two. So I'd like to go through that with you and understand the boundaries. The other thing that will come up with something like geofencing is the type of constraints that government entities might use on such. So we'll have to be very careful in how this is used, what domains it's applicable to. Right, no, but we won't put that in the draft, right? We'll have to think carefully about what the constraints are. So I just wanted to note that.
So I'm going to jump in here for just a second because we're kind of out of time. We're 5 minutes into the next presentation. However, I didn't hang on. I didn't get a presentation submitted for the next talk. I'm looking at Michael.
Also you.
What was that?
You had
The-
geofence and geographic results.
They're together.
Okay. All right. So we have more time.
Oh, so Dave can speak.
So Dave can speak.
Go ahead, Dave. Thank you.
Hey, thanks. So as I posted in the chat, the draft that Michael is asking for adoption of, the LKSPA RATS verifiable geofence, does have section 6.2.2 on GNSS spoofing, and that was the point that I raised the last one. And so I was happy to see that there is a section on this to call out in the security considerations section about the spoofing. And so, but yes, thanks for addressing my comment and putting text into the document that talks about it.
Thank you. Great.
The agenda ran early.
Yeah, I did.
That's bad news because now there might be time for questions.
We might have time for questions.
Yeah, it's unfortunate. Okay. I'm expecting that this one may have a fair amount of discussion. This is a document that Hannes and I, along with Hannes's master student Giuliano, are putting forward. This is meant to be a discussion starter. So this is not meant to be a full solution. This is not meant to be really necessarily solving anything in its OO. It's meant to put out there, do we have a gap in the RATS architecture, which I'm not convinced we necessarily do, but we want to ask that question. And if we do have a gap in the RATS architecture, do we want to do anything about it? And the answer might be no. But this is meant to spark a discussion. You happy with that framing?
Yeah.
Yep. And maybe volunteer to help solve a problem.
Sure, there might be a solution coming, maybe. And so first off, this is a framework. This is not proposing anything technical. This is proposing a framework in which you could design technical things, but this is itself not a solution. It is a framework for designing solutions. Okay, I get a clicker. I got a clicker?
You got a clicker.
Ooh, clicker. Okay, core problem. Giuliano has defined this brilliant term, which is the core of his thesis, called coercive use of RATS. So if you say, in what contexts could somebody force an attester to produce attestation that it probably doesn't want to produce, or that harms itself, or that harms its user? And if you take that problem statement, and you go looking in the world for places where you could coerce an attester to attest when it really shouldn't, or coerce a verifier to produce an attestation result when it really shouldn't, or hand those things to a party who really shouldn't have access to them. If you just start looking for things, you can find them. Yes. And the if we sort of whittle this problem down to its core, if we try and sort of academically distill this problem down, I think we can distill it down to the statement that the RATS architecture does not address the possibility of a verifier being malicious. We typically think of the verifier as the entity that is enforcing trust. They are the good guy. They are trying to find compromised devices. But nothing in the RATS architecture really asks, but what if the verifier themselves are the bad guy? And I think if you start asking this question, and this could be actively or passively, right? They could actively be the bad guy. They could be, the verifier could be an attacker trying to hack a piece of hardware and using the RATS channels to aid that attack, right? Active attacker. Or the verifier could be passive in that like they're producing logs that end up leaking some PII or something, right? And I don't think either of those scenarios are really well addressed by the RATS architecture. So let's run through some simple examples. By the way, I'm going to use the same slides at SAG on Friday. I'm also presenting this on Friday. I convinced the security ADs that this problem, while it is obviously a RATS working group problem, it has implications for other working groups who consume RATS. So we're also going to popularize this idea at SAG. Okay, problem number one. Yeah, you've got some mobile device and some web service that through a browser pings it for attestation. The phone then attests itself. I'm Fun Phone 7, blah, blah, blah. And the web service says, sorry, your manufacturer didn't pay the right licensing fees. You don't get to access this service. I think most of us will agree, generally speaking, for open, good access, fun, human internet should be free. The fact that this is possible, the fact that a web service can block access to a service based on what hardware you're running, not whether you're logged in, not whether you've paid a subscription, but whether your device manufacturer is on the good list. Generally fine in like an enterprise setting, but generally bad for open internet. So part of our goal here is to give the attester more control over where and when it agrees to provide attestation. Version B of this problem is, let's say you have an HSM and you're trying to hack the HSM and you're going to interactively interact with RATS in order to help the whatever attack you're trying to do. In this case, tell me your firmware number and that tells you what CVEs you're vulnerable to. You can imagine there's various ways that RATS can be used to help a local attack. Okay. So the solution to this problem, to both versions of one, is that the device should be able to say, sorry, you're not authorized to view that claim. And that nicely closes off this sort of category of things. But this is a fairly complicated, there's a lot of steps involved to be able to say you're not authorized to view this claim. You first need to know who's asking. And in RATS, the verifier is not an authenticated role. The verifier doesn't have an identity. It doesn't have to prove who it is to the attester generally, right? So there's a bunch of prerequisites to be able to even do this. We can also talk about confidentiality of evidence. So we can talk about whether the evidence is encrypted and who it's encrypted for, whether it's encrypted purely as channel encryption over TLS, or whether it's encrypted as object encryption that stays encrypted as it passes through all the HTTP gateways. Really, you'd think it should be encrypted all the way to the verifier, so then the verifier needs an encryption key, all that stack of stuff. And I will point out that both 9334 and EAT allow for encrypted evidence, specifically CWT and JWT encryption is allowed, but it's sort of allowed in passing. I wouldn't say there's a good, robust framework with solid best practice guidance for doing so. So I'd say allowed, but not robustly specified. So if we come to general shape of solution, oh, my cue is lovely. Okay, if you come to general shape of solution, we're just following the standard CIA thing. If we're considering that the verifier or RP could be malicious, well, then we need to confidentiality, integrity, authenticate it. And that's it. That's the whole thing. So integrity is done. We don't, RATS already does integrity nicely. Confidentiality, I'd say, exists, but isn't well specified. And authentication, probably not very well specified either. Probably my cue has understood what we're doing enough that I can take it. So yeah, our draft does the things you expect our draft to do, and it defines a framework in which you could define specific technologies, and the framework does what you expect. I'll leave this up and take my cue.
All right,
Nathaniel.
6 minutes total.
Daniel.
For next steps.
You can try.
So I just wanted to say that I've gone through the draft. There's some questions that it raises regarding things like verifier trust that were interesting that I hadn't thought about before. That it's like, okay, yeah, that's well motivated. I recently published a informal symbolic proof, experimenting with object level encryption of evidence that is opaque to the RP that the verifier can unpack and verify that, it's a privacy thing only, it doesn't affect integrity. And then I had selective disclosure, all of that worked out. So in terms of the logic and everything else, that seems to be working. And I was desperately looking for this for like 2 weeks before this showed up. So I like it a lot.
Okay, each person has 1 minute with the response.
Okay, I just wanted to disagree with the premise of how you represented the RATS architecture. We said when we created the architecture that the roles are independent of the entities upon which they are hosted. In other words, the actors are the nodes that are responsible for establishing secure access. So it's a layer underneath. The roles are composable. You can put different roles on different hosts, but it wasn't our focus to say that we're going to define a security model all the way down the stack in terms of how entities discover each other and how they determine that they're going to interact with one another.
That's fair. And then the question is, should we?
But the premise is we had to get the premise right before we can have the discussion. And the premise is, as stated, was something like, hey, any RATS attester has to interact with any RATS verifier. And if the verifier asks for something, you have to give it to them. That was not anywhere in the RATS architecture.
Okay, maybe consider that before your SAG presentation.
Yeah.
Osama, less than a minute.
Very short, less than a minute. I agree with Ned.
Great.
Saying.
My question is the incentive to enable the privacy consideration, because like you go to the museum, you go to some country, you ask for visa, they need to provide your passport, to provide your travel experience in last 10 years. You need to go, you need to give all some to them. So it's verified decide, it's not a tester decide. So how to enable such kind of incentive?
It should be user decides.
But for example, to apply a visa, can I say that, okay, I refuse to give my last 10 years travel history? No, I cannot.
Well, you can refuse. You can choose to not enter the museum.
Yes, so I mean, I refuse to use that verified service. I refuse to connect with the relay party.
Yeah, that is a choice you should have.
Yeah.
And I'm not sure that the technical
So
frameworks
finally,
always
I
give
do
that
not
choice.
get service. So you see, this is the incentive is important, right? And with zero knowledge, you increase the cost. So how to have such kind of incentive?
Understood. Understood. I understand your comment, Dave.
Back on slide 5, you made a comment, and if you flip back to slide 5, just for the context, I have a specific suggestion for how you deal with stuff in the draft, which I haven't read, so I'm only commenting on the slides. On slide 5, you said that the concept of authenticated review of the claim does not exist in RATS today. And your voiceover, you talked about there's no concept of how the attester gets trust in the verifier. And I think that by itself isn't true. And I think what you want to do is you want to split your discussion into 2 cases, the background check versus the passport model. In the passport model, the attester has a specific relationship with the verifier, right? Just like the previous speaker says, if you're going to apply for US passport, you're choosing to have a relationship with the US government or whatever. And so that's a priori established. And so that's one case. The other case is when you have background check, in which case the attester has no clue who the verifier is. That's a choice made by the relying party. In that case, you're saying, I'm choosing to send stuff to the relying party. And there is, I think the way that you phrased it is just fine, right? And if stuff goes to a verifier, that's no different from anybody else you choose to trust, passing your information on to somebody else that you have no knowledge about, right? And you're either choosing to trust them and what they're going to do with it, or you're not, right? And so I think if you split it into the discussion of those two cases, you'll end up with kind of different statements there because you have different trust relationships with the relying party. And not the verifier. So
the slides are simplified. The draft deals with, we deal with the evidence case versus the attestation results case separately in the document. The slides are a bit, maybe sloppy.
All right, Hank.
We're out of time, by the way.
20
But I
seconds
have
now,
1 minute, Ned. Going back to what Dave just said, yes, the passport model is pretty safe in this case. The background model explicitly says that since evidence is merely forwarded to a trusted verifier, that is explicitly stated for the background check model. Because of that problem, I think we at least account for that fact. In the privacy consideration for the PII, we highlight that only sending such evidence to a trusted verifier is necessary, because otherwise it would be very stupid. So that's a framework part that is missing. No, not missing, actually.
Right, well,
and then for the conceptual message protection, we say that any solution should have the end-to-end protection, authentication, auditing before sending it. So all your concerns are literally addressed by text in RFC 9334. There needs to be a solution to the problem. Of course, there's no specification that does it. And also you start all your premise with a assumption that is on slide 1, which is an IAB statement. And that we will talk about 10 to 15 minutes about in SAG.
Yes, I mean, this is essentially trying to expand what trusted verifier means into a whole document. Effectively is what we're doing.
Well, I think that is very fine.
Okay, thank you. And I think this was helpful so that you can incorporate changes before SAG so
I
that
wanted to start a debate, and I seem to have done that.
let's my suggestion as a chair is let's frame this in a way that's helpful so that there is support and good collegial work.
I will
to be
take
done.
feedback from here and adjust the slides before SAG. This is great. Thank you.
Thank you. That's right. If you're offering help, frame it that way.
Okay, we're done.
Thank you all. We'll schedule an interim as Ned had said, and thank you. Get good work done.
It was combined with the previous.